The following video shows how to set up the lathe in the home workshop. If done correctly, the cuts will be clean and accurate. Starting with the base, you're going to have to add backing underneath until the top of your table is flat and true. This is necessary for accurate turning. With the base correctly set up, we can move our attention to the lathe itself. The first thing you need to do is set up the sliders. This is relatively easy. After loosening each adjustment point, they need to be tightened from the inside outside, and this is quite important. What you do is you tighten the grub screw, you move your sliders back and forth to see that you haven't added too much tension, and then you lock it with the lock nut. After doing all of them, you check your slider again to make sure that you haven't added too much tension. The idea is to get the slider to move freely without too much friction, but there needs to be no play in the slider itself. Noticed that at this point we haven't bolted the lathe down to the base, and there's a very good reason for this. If your lathe is not accurately bolted, you'll end up adding unnecessarily twist to your bed. Of course, with any bed direct off a production line, there will be a certain amount of twist inherent in the manufacturing process. So you would need to correct for that, and this setup will show you how to do that. The thing that you would need is a length of round bar. 20 diameter should be fine, but it needs to be ground. It needs to be accurate along the length so that we can determine if there's any twist in the bed. The ground bar needs to be set up in a 4-jaw chuck. The reason being is a 4-jaw chuck you can set up a lot more accurately than a 3-jaw chuck. The 3-jaw chuck will never have 100% run-in. So with a 4-jaw chuck, if you center it 100% at your base with this ground bar, you get a very, very good idea of how parallel your bed is. Let's go through this step by step. Once your ground bar is in your 4-jaw chuck, you center it as best you can. Then you move your dowel gauge close to your base, and then it starts the laborious task of getting it to be 0. As you can see in the video, it's never 100% when you start, and this does take a lot of time. So this setup could really take a couple of minutes, so let's just speed it up a little bit. So while I'm setting up my ground bar and my 4-jaw chuck over there, let's just have a look at what effect this has on your cutting. Let's say that the far end of your bed towards you is lifted up higher than it should. That means that your bed is pulling away from your tool post the further you go away from your chuck. You'll end up with a taper as you cut. The problem is, the further away you are from the chuck, the worse this actually is. And if you're doing long pieces, you really end up with poor cutting. Finally, we have a 0 reading at the base of the 4-jaw chuck. We now move the dowel gauge out away from the 4-jaw chuck. We find the minimum and the maximum, and then the average between those two is your set point. I've added a convenient jacking point that makes adjustment much easier. If you don't have this, you're going to have to shim. If you have a look at your tailstock side and you shim the point closest to you, if you go positive, you're moving your tail post and your bed away from the tool post. That means that you would decrease the reading on your dowel gauge. If you decrease it, you would increase the reading. And in so doing, you will find the 0 point where you'll cut absolutely parallel. For the average workshop, this method of setting up your lathe will be pretty good for most applications. If you're going to do extremely accurate work, then this is just not accurate enough, and you're going to have to go one step further. I'm going to show you how to do that next. The most accurate way of setting up your bed is to machine an actual test piece. To give some orders of magnitude, a standard dowel gauge, like the previous setup that we did, will probably give you about 10 micron. But if you have a micrometer on a test piece, you can measure about 3 micron. With this in mind, a test piece measured roughly 100 millimeters away from your chuck, and definitely no less than 25 millimeters thick, from point A to point B should be less than 2 microns different. When you're cutting, you need to use a finishing tool with very light cuts to make sure that your cutting is not pushing away your test piece. That's one of the reasons why you need a bar that's more than 25 millimeters thick. And this lathe, as you can see, is absolutely parallel. The bed setup, the last thing to do is to set up your tailstock. Mine lathe has got an MT5 taper in the spindle. It's never 100% accurate. The only way you're going to get a point that's absolutely perfect is if you machine it on the bed that you're using. And if you leave it in your chuck, it'll be perfect every time. If you take it out, you're going to lose that accuracy. This is an easy way to set up your tailstock. Bringing your tailstock towards your machined point that you've just done at your chuck, you can get very, very close to perfect. But again, if you need zero taper on a relatively long shaft, then this is just not going to be good enough. And the next step is to show you how to set up your tailstock perfectly relative to your chuck. To do this, you're going to need a standard test bar. This bar is a very, very accurate bar held between two centers. It is perfectly parallel. And when between two centers, a dial gauge run from one side to the other, you're looking for very, very little drift. You may be asking where you get one of these test bars, and simply you make it yourself. All you need is a driver and a dog, and stick it between the two centers, and you machine it down until you got about 2 micron difference from the one side to the other. If this is done correctly, when machining, you can take 2 to 3 millimeter cuts with very little effort and a very good surface finish. Also, with the workpiece in a chuck and a dead center, you will have very, very little vibration in dead center side. I hope that this video has been helpful, and the projects you get from your lathe are as rewarding as the projects that I've done on mine.